There we go. We have 7 radical 10 plus 4 radical 10. These are the same radicals, right? These are like radicals because it's a square root for both, and then the radicand is are both 10. Therefore, you can do 7 plus 4, and that gives you 11 radical 10, right? Same on number 41. You have the square root of 3x, and then the square root of 3x, so you could do 5 minus 2 is equal to 3 square root of 3x, right? And number 42, you have the cubed root of 2x, cubed root of 2x. So these are the same radicals, right? So you can do 7 plus 3 is equal to 10 cubed root of 2x, right? Easy stuff here. 8 radical 10 minus 3 radical 10 is 5 radical 10, plus 2 radical 10 is 7 radical 10. So those should be pretty simple. Now number 44 is where it starts to get more interesting. You have to actually simplify each radical before you can add or subtract, right? Before you can combine. So let's simplify each of these. So radical 72. Remember, you're trying to look for the highest perfect square that's in the 72, which is 36, right? 36 times 2. And if you don't, that's okay. You still end up with um, the same number. So this is 6 radical 2. And then radical 50 is radical 25 times radical 2. So that's 5 radical 2. Let me zoom in a little bit here. Okay. So now that you have 6 radical 2 plus 5 radical 2, you should get 11 radical 2. Okay, any questions so far? Okay. Let's see here. Radical 54. So what do you see here? Do you see anything? Now, if you can't see the largest perfect square in 54, you could just try, different numbers that you know it divides into this. For example, if you can't think of it, right, you could just say, oh, okay, let's just divide the 54 by 2, right, and then we'll get a 27. So let me do this off to the side so it doesn't take up too much room. And then you got the radical 27 is what? Hopefully you get like a 9 times 3 here, right? So let's say you got 3 and 9. So then you can see 9 is the largest perfect square, right? So if you couldn't think of it that way, you could just do that and multiply the rest. So you get 3 radical 6. Otherwise, you should have gotten from here root 9 times root 6 is equal to 3 radical 6. Okay? And then the radical 24 is just radical 4 times radical 6 is 2 radical 6. So this is 3 radical 6 minus 2 radical 6 is 1 radical 6. Okay? Alright, let's see. Hopefully that looks familiar, right? Okay, let's try some more. So you got 9 radical 7 minus 2 radical 63. These are not like radicals at the moment. Radical 7 you can't simplify. However, at least the radical 63 you can. Now, usually when you're combining, right, adding or subtracting radicals, most of the time, the other radical is going to have a radical 7 in here. And you can see it, right? It's 7 times 9. So let's say I did the 2 radical 63 is equal to 2 radical 9 radical 7. So then that's 2 times 3 radical 7 is 6 radical 7, right? So now I know this is 9 radical 7 minus 6 radical 7. So 9 radical 7 minus 6 radical 7, and what does that give us? 3 radical 7. Any questions with that? Okay, so we'll just do up to 47 and then move on. So radical 20, we know that's radical 4 and 5. So that's 2 radical 5. Radical 45 is 9 and 5, right? So that's 3 radical 5. And then the last one, 2 times radical 25 times radical 5 gives us 2 times 5 radical 5 is equal to 10 radical 5. So hopefully by now, or maybe you got rusty over spring break, but hopefully by now you are all pretty good at simplifying each of these radicals. So you have 2 radical 5 minus 3 radical 5 plus 10 radical 5, right? And that should give you 9, oops, sorry about that. Yeah, 9 radical 5. Are we okay here? All right, let's move on to some of the multiplication that we did. Okay. Kind of cool today. All right, so we're multiplying, and we can really only multiply when the roots, the index, is the same for both radicals, right? Let me see here. Use a skinnier pen. So this is a 2 and a 2. So since they're both square roots, you can combine them all under one radical, right? Using our product rule of radicals, like that. So this becomes radical 21 xy, right? And then you can simplify if you like, or if it's possible, I should say. I'll just do the left column first, and then we'll move to the right. This is the cube root, right? Cubed root. So we can combine these as the cubed root of 4a cubed, b cubed, and this simplifies, right? The 4 does not. Oh, whoops, let me write the... So the a cubed root of a cubed is a, cubed root of b cubed is b. So we have ab times the cubed root of what you cannot simplify. All right, 59, we have square root of 6 times this quantity here, in parentheses, radical 8 minus radical 2. So if you recall, we were supposed to do distributive property, right? Distributive property, like that. So yeah, you can multiply them and get radical 48 minus radical 12 and then simplify, right? And then simplify, or I don't know if you remember from what we talked about last time. I know that this 6 is 2 and 3, right? Radical 2, radical 3. And this 8, I know, is radical 4, radical 2, which is 2 radical 2. And this is just radical 2. So when I'm distributing, I'm looking at radical 6, which are these numbers, times radical 8. So I see radical 2 times radical 2 is 2, right? So 2, and then this 2 is 4, because you're multiplying, times radical 3 is 4 radical 3. Does that make sense? Did everyone get that? If you got that or understood that, can you type in chat that you did? I'm going to move on to the second term. Now you have radical 2 times radical 3 times radical 2 here, right? And we're subtracting. So 2 radical 3 is equal to, like radicals, 4 minus 2 is 2 radical 3. So that's the way I kind of do it in my head, so that I don't have to deal with larger numbers. But, you know, if you prefer it this other way here, you can simplify radical 48, which is what? Radical 16 times 3, right? So that's equal to 4 radical 3. And then radical 12 is radical 4 times 3. So that's 2 radical 3. So yeah, you can do that. That might be easier for some people. Okay, we did not cover 61 yet, so we'll do that today. Let's move on to the right column. Alright, we have square root 6x squared times the square root of 18. Right? So you see what I'm talking about here? This number becomes quite large. This is 108, right? And I don't want to do that. Instead, I can see the 18 as radical 6 and 3, only because I see a 6 here. Does that make sense? So ultimately, yeah, when you combine them, it looks like this. Right? This is my 18, 6x squared. So I know this is 6, right? I know square root of x squared is x, or technically the absolute value of x, right? And we're assuming these are positive for these problems. And what's left? The 3. Okay, radical 5 times, so we're doing distributive property here, right? So I notice 5 times 3 doesn't simplify. So that's just radical 15. And then 5 times 5 times 2. So that's just 2 radical 5. So you cannot, multiply these under the radical because this is not under the radical. All right? And then the last one, number 60. The a's cancel out, right? And the a's cancel out. But I see this radical 125. I'm going to just kind of work on that right now. That's 25 times 5, right? 5a. So that's 5 radical 5a. That's radical 125a. So now I'm going to do distributive property with this number here, with this 5 radical 5a. So I see this is equal to a radical 5 plus, and then the a's cancel out again. So the 5a comes out here, radical 5a. So now these are like radicals, right? Oh, I'm sorry, the a comes out. Let me erase that. So now we have a plus 5a is 6a radical 5. Alrighty? Okay, well those were the problems. Let's move on. Here we go. So today we're going to learn how to distribute twice, kind of like when we were doing foiling for binomials, right? Okay, so this one's not too bad. If you remember foiling, I'll just show you real quick. If we had something like this, right? 2x plus 3 times 5x minus 1. Remember distributive property twice, right? Foiling. First is my 10x squared. Outer is what? 2x times minus 1. So that's minus 2x. And then we did the inner. 3 times 5x is positive 15x. And the last, 3 times negative 1 is negative 3. Then we have to combine the like terms, right? So these two middle terms. So we got 10x squared plus 13x minus 3. So that's FOIL, right? So we'll do the same this time with these radical expressions. So first is radical 3 times radical 3. Let me use a thicker. All right, radical 3 times radical 3. So that gives me my first, which is right here. And then my outer is radical 3 times 5, so that's just 5 radical 3. The inner is the next term here, 1 times radical 3, and then the last is 1 times 5. So radical 3 times radical 3 gives me 3. And then this is 5 radical 3, right? 5 radical 3 plus 1 radical 3 gives me my 6 radical 3. And then my 5 right there. You combine 1 and 3, 3 and 5, and you get your 8. Okay? So let's try. Another example here. So as you can see, we FOIL, right? When you FOIL, you get radical 6 times radical 6. That's here, right? It's my F. And then radical 6 times minus radical 2, right? So that's my outer right here. And then radical 2 times radical 6. So that's positive, right? That's my inner. And then my last, right? Okay, so hopefully y'all see that. Root 6 times root 6 is 6. Then you have minus root 12, right? This is minus root 12. And this inner term gives me plus root 12. You see how these cancel out to 0? That's why it's 0. And then lastly, minus 2. So this is my first, this was my last, and then the middle two cancel out. So this was called a difference of squares. Do you remember that? Difference. I told you this was an important concept, right? Difference of squares. The middle two will always cancel out. Then you have 6 minus 2 is equal to 4 as your final answer. Okay? Now, quick review on, not review, but quick thing about conjugates right here. When you have a radical 6 plus 2, right? You see how this plus 2 here, and then over here is a radical 6. You change that to a minus 2. Those are called conjugates. Right? So these expressions are conjugates of each other. Okay, so that's something we're going to need to know little later on today. But before we do that, let's just keep practicing these until we get more comfortable. Alright, now we're going to do a binomial squared. Binomial squared, if you recall, it's this term, this expression here, expanded. You have the squared means you multiply it by itself twice, right? So radical 2 plus radical 5, it is a quantity times radical 2 plus radical 5, right? So once you expand it, you can FOIL. So first, right, this is my first. Then you got your outer, that's positive, right? Inner, right here, and my last. So first, outer, inner, and last. Root 2 times root 2 is 2. Root 2 times root 5 is what? That's root 10, right? Oh, it's right here. And the same for that. And then lastly is 5, right? So root 10 plus root 10, that's 2 root 10. 2 plus 5 is 7. So notice you write the non-radical term first, and then the radical term after that. So 7 plus 2 root 10 is the answer. Okay, any questions? And as a reminder, this is a binomial squared. If you remember from chapter 5, right? When you had a plus b per quantity squared, it's always following that formula a squared plus 2 times a times b plus b squared. Right? In this case, a is root 2, right? Root 2, this is your a plus b. So b is your root 5. So if you had done it that way, you can see that the first term would have been what? Root 2 squared plus 2 times root 2 times root 5 plus root 5 squared. So this would have given you 2 plus 2 root 10 plus 5 is equal to 7 plus 2 root 10. You notice it's the same solution, right? So if you do know what the formula is, do you see how it can benefit you? So with that, I want you to try these 3 problems. I'll give you a few minutes. For those of you who can just watch the video. Alrighty, so we have 5 over radical 7, right? That just means we have to do 5 over radical 7 times radical 7 over radical 7. So that's 5 radical 7 in the numerator over 7. And also I like to check outside the parentheses, the radical, if the fraction can simplify or not. Alright, the next one, we have radical 3a over radical 5b. We need to multiply this by radical 5b over radical 5b. So the numerator is radical 15ab over 5b. Alrighty, and lastly, we have 5 over the cubed root of 9. So here's a tricky one. This one, I want to use the number that's the smallest here. Technically, this 5 over cubed root of 9, 9 is actually 3 squared. So that's why I want to multiply this by the cubed root of 3. Okay, now check what I'm doing here. I got 5 cubed root of 3 in the numerator over, you see now this is 3 squared times 3. So this is cubed root of 3 cubed, which is equal to 3. Does that make sense? That's why my final answer is 5 cubed root of 3 over 3. This is the final answer. Now, I'm going to show you, if you didn't do that, let's say you had multiplied by cubed root of 81 instead, that would have given you a lot of problems later on, right? So if you had done 81, this is much larger, it would have been too difficult, right? You see the point there? So that's what you want to do. You can multiply by something to give you the smallest cube. So this one you do have to know your cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed, 27, 4 cubed, 64, at least up to 5 cubed. Right? So that's how I knew this had to be a 27 in the end, right? So I have to multiply by cube root of 3. Okay? Alright. I believe we could skip these for now. These will be going over in the next course. Alrighty. So hopefully that was a good refresher from last week. Now today, let me start recording. We have the square root of 2 plus 3 times the square root of 2 plus 5, right? So if you recall, we're going to FOIL. So root 2 times root 2, right? Root 2 times root 2, that's my 2. And then my outer is plus 5 root 2, right? My inner is plus 3 root 2. And my last is 3 times 5 is 15, right? So now I can combine. So 2 plus 15 gives me 17, plus 5 root 2 plus 3 root 2 is 8 root 2. Alright, how many people got that? I hope, you got it, or you're pretty close. Alright, I'll let you finish B and C. Okay, we have radical 5 times radical 5, right? Radical 5 times radical 5. And then we have radical 5 times radical 3, so that's positive, right? And in the inner, we have minus radical 3 times radical 5. And then the last is minus radical 3 times radical 3. So as you can see, this one is equal to 5, right, plus radical 15 minus radical 15 minus 3, right? So 5 minus 3 is 2, and radical 15 minus radical 15 is 0. Therefore, the final answer is 0. All right? Any questions there? All right, last one, I'll just write it out here. We have to expand it, right? So radical 7 minus radical 3 times radical 7 minus radical 3. So you could do it two ways, right? There are either two ways. The first way is to do it by FOILing. So the first term here is radical 7 times radical 7 is 7. The outer is minus radical 21. The inner is minus radical 21. And the last is plus 3, because minus times minus. So 7 plus 3 gives me 10, minus 2 radical 21. So that was the first way, right? And the second way is a squared. So this is a minus b squared, right? So if you recall, a minus b squared is equal to a squared minus 2ab plus b squared. So what's a squared? A squared is radical 7 squared, right? So radical 7 squared minus 2 times radical 7 times radical 3 plus radical 3 squared. So this is 7 minus 2 radical 21 plus 3. So that gives me 10 minus 2 radical 21. Right? So either way you do it, you get the same answer. All right, well, let's move on. So we did talk about dividing radical expressions, right? And we talked about this property here, right? If you have a cubed root of a over, an nth root, well, we did it for the square root and cube roots, but if you have the nth root of a over the nth root of b, you can combine them under one radical, right? And say it's the nth root of a over b, just like that, okay? So we just have to remember to rationalize the denominator here, right? So we have in letter A here, part A, 3 over radical 5. So since that one we have to rationalize, we're going to multiply this by radical 5 over radical 5, which is equal to 1, right? So 3 times radical 5 is 3 radical 5. Radical 5 times radical 5 is 5. So now you don't have a radical in the denominator, right? That's called rationalizing, which we covered last week. All right, so in part B, you have radical 7x over radical 10y. So to rationalize this denominator, we have to multiply this by radical 10y, right? So radical 10y in the numerator and the denominator, right? Because this is what is equal to 1. So we're multiplying this by 1, basically, right? So in the numerator, you have radical 70xy over radical 10y times radical 10y, right? That's just 10y. So that's the denominator. For the cube roots, you're going to have to think a little bit. You have to remember what cubes are, right? So you have, notice for the square root, right? This is, You only need it written twice, multiply it by itself. There has to be 10y times 10y, right? And then the square root cancels out with the square. But in a cube root, you need something to the third power to be canceling out. For example, if I do 2 to the third under the radical like this, it's equal to 2. If I do 3 to the third, it's equal to 3, right? Cubed root of 5 cubed is 5. So that's our goal. We have to multiply by some number so that the radicand is something cubed. So 3 over cubed root of 2, that means I have to multiply this by a cubed root of 4. Why is it 4, you ask? Well, look at this. 2 times 4 gives me 8. So you get the cubed root of 8, right? What is 8? 2 cubed, right? So cubed root of 8 is 2. Therefore, you get the final answer 3 times the cubed root of 4 over 2. Okay, so that one's probably going to take you some practice. But yeah, you'll be able to get it. So with that, please try these examples.